Hello once again, YouTube. This is me doing homework right now. Watch this. Boom. Oh, organic chemistry. How would you synthesize this problem into this one? Well, I don't this structure. I don't know the names. I didn't do the namings, but first thing we'll do, not have an eraser. We'll draw this. How are we gonna make it have this oxygen? This right here. How are we gonna do that? Well, there's a few things we need to do. First thing we can do is hit it with MCPBA. Now what that's going to do is make it into an epoxide, I believe. Put the oxygen right there. Drew it a little wrong, but you know. So this provides functionality to this carbon right here, that carbon right there, which is what we need to get this bond on there. I mean, not bond, get that double bond oxygen up there. So first thing we could do is not right click. After this we could do LAH. Well, it's a two-step thing. We do one, and then that is not a two. Two, water, follow it up. And let's move on to the over here. So, and that would put an alcohol on this carbon right here. Same one, we want that double bond oxygen, and now it's quite simple. We just end it off with PCC and CH2Cl2, and boom, our product. Now that one wasn't a really hard synthesis. None of these are. Here, that's the whole thing. That's the whole problem. Quite simple, really. Now there's two ways of going at this. We did it the one way with this epoxide. I think it's an epoxide. Yeah, it's an epoxide. Yeah, yep. So the other way you could go about this is the simpler way. The way that I would do it is just by hitting this with what do I hit it with? H2SO4 and heat. Now what this does is basically it skips this step completely and just makes this an alcohol. And now we already know this step from up here. It's just a PCC and CH2Cl2. Now, if anybody sees this video and notices me having a mistake, please comment down below. I am a student, and you know, I am not a master at this stuff. Still learning it. But we could do some more things. Let's see what else we have in here. Ooh, this is a fun one. Okay, we'll go away from here. Look at this one. So we have this as our starting material once again. I think that's the same exact one. Yep, same starting material. But then we go to get a load of this. SH and an OH. Two functional things. This one and that one. Now, how would we go about this? Well, same way as last time. This time you need to do an epoxide because it would put functionality on both of these carbons. I mean, you could, but so we could go about it as let's see. Let's use something else. Let's use our CO3H. I think that's one of the things that does it. That makes an epoxide out of a double bond. So then we could go like this. Let's try it more neat way. Oh, that looks so bad. That's... I'm just gonna redraw it, the whole thing. I can't see my eraser. I cannot see my eraser. I'm doing this blindly. Uh-oh. Can't see anything. Oh, now I can. Oh, now I erased. See, this is pain. RCO 3H. I don't know why that looks so weird, but... And then we create our... And the O... It's just so bad. It's not my day. Now, there's two ways of going out this acid catalyzation, which is interesting. We'll draw both. So, first way is just N. Oh my gosh. It's not an N. N-A-S-H. That's not space is not supposed to be there. 1 N-A-S-H, 2 H, 2 O. And that will get us to our product. Or we could go, boom, acid catalyzation. We'll do H3O plus. Could also do H, just H plus. And H2S. Excuse me. That once again will get us to the same thing. That is a little weird looking, but it's what it is. It is what it is. Now that was quite a simple one also. Now, time for a... Let's see, should I do that one? Yeah, we'll do one more. We'll do two more actually. So, we'll take a ring with a BR hanging off of it and take it to this monstrosity. Ooh, that was not centered. I don't have any lines on this paper, so I don't know where is which. And this thing that I'm drawing on is not that good, but I like it. So, you know. Now, how did we get here? It's quite... I find this one easy because BR, usually a halogen, usually means you could use a Grignard, which would create this carbon-carbon bond that we need right here. Right here. So, let's do that. Let's make this a Grignard. BR, and then boom. Where's the MG? And then comma space THF. And that will make this into, you know, just MGBR on this ring. Now, what would we add to this MGBR to make it into this? There's two things we could actually add, I think. I think we could do it. No, there's one way we could do this, which is just by doing it the traditional way. Adding a double bond oxygen like this. Step one. And this is because we basically added this whole thing. And then two. Watcher, followed up with watcher. I don't know. And that brings us to our final product of No, wait, that does not bring us to a final product. I'm mistaken. That brings us to... Ooh. Ooh. Ooh, yeah. That brings us to this. An OH right there. But that should be easy enough. We all know how to make OHs into double bond oxygens. This. And then we'll do... I think it's water. What? I am... We could double check, cause no, it's CH2Cl. What? Oh man, see, I already forgot. CH2Cl2. Ooh, look at that. Whoa, you can make them into perfect lines. That one's not perfect, but boom. Oops, I forgot to just do everything that I was meant to do. Too distracted by the lines. Messing up all my perfect lines, guys. Is it gonna do it? Nope, it didn't do on that one. It's too curvy. But now, okay. Now it's time to do this annoying one. The one we've all been waiting for. I don't even think this one's right. Because we skipped step. We did this one in class because it was so complicated. So basically, you have a... We'll clarify things first. pH, not that H, small h. pH equals phenol, which is, you know, as you guys know, who's watching my educated organic chemistry, is just a 6 ring with alternating double bonds. But we'll draw the whole thing. But I will at first, so... Draw that. Boom, there's a double ring. The double ring, I think it's here that it's bonded. I don't remember. Is it gonna do it? Nope. Gonna do it? Yep, there it goes. Oh, that is a weird looking line. Not using that. There's an oxygen there. On there, and then we have a wedge here. Let's color it in the best we can, because this is not... That's a solid wedge, that's not a dash wedge, you guys can tell, but... And then we have a dashed wedge. Ooh. Going here to a hydrogen. This going up. Why did it do that? It's going up. It's going down. Oxygen here. It's going across. It does it only sometimes. It's annoying. I'm not going to do that the whole time. But there's that one. The dashed wedge going out to oxygen. And double bonded oxygen. And there. That is done. Now, draw a mechanism for this to turn into... Let me draw the product now. I'm not even done. See, I'm just going to abbreviate pH. O. Ooh, that is a weird looking... I don't even know if there might be even a fill tool that I could be using to fill in these wedges. If only I knew. Now I have to draw the mechanism for this formation. I don't know, that does not have a thing. Okay. It's already been 15 minutes, but, you know, we're practicing. Boom, and boom. Draw the formation from this to this. And I was like, what the heck? You know. But it uses acid catalyzation, which we didn't show how. We didn't show the whole mechanism, but we basically did this. Here, let me get my... Where are my colors? Where's my colors? I'll show you the strategy we did for this. So we number the carbons, every carbon 3, 4, 5, 6, 7, 8, and 9. Numbered them like that. Don't ask why, but this is 1, this is 2, this is 3, this is 4, this is 4, this is 5. This one is 5, this one is 6, this oxygen is 8, it's the same oxygen. This one's 9, and this one is 7. So then, as we can see the same layout, it just moves it and folds it in like that, which is really quite annoying, if you ask me. So we're just going to label this as R1, so I don't have to redraw it every time. So it goes R1, solid wedge, now we're going to draw it in an interesting way. Actually, we can show the first part of the mechanism right here. Label in orange. Oops. Label in orange. We need to draw. Actually, we need to draw its lone pairs first. Because we're using them. Now, this oxygen will go all the way around and attack this from the back, which will then push this bond up onto that oxygen, which will then leave us... I'm going to do it the same way I did in my notebook. Have them too close together. Gosh, I am coughing today. We'll have R1, not double bonded, solid wedge bonded to this oxygen, dashed wedge to this hydrogen. Ooh, look at that. Oh my gosh, I thought it was going to be good. Nope. Goes to that, goes to a solid wedge. Goes to a dashed wedge. I don't know why they're all curved. Which goes to an oxygen, which goes to our... There's a new bond here that we formed. Goes to our third oxygen. We're redrawing this slightly so it's bent up in the favor that we wanted. Oh, shoot. These double bonds is still connected to this oxygen. And then here is number 7. That's number 7 right there. So we have the same number of carbons. We just added this bond here. We folded it in, broke the ring. The acid catalyzation would break that ring. and create all the charges on this. Because this oxygen right now has a lot of electrons and a positive negative charge, not a positive. The other one has a positive charge. And this one has a positive charge. So the next thing that would happen is these electrons go up into that bond, which will then break that bond, going onto that positive oxygen. So then after that, we draw the same thing. Ooh, I'm drawing it the opposite way this time for some reason. No, we're not. Oops. But yeah, you can is a solid wedge. H. Then, whoa, look at this. New bond alert, right here. Boom, look at that. Oh my gosh. Eraser, turn off. This goes to that one, which goes to this. That dashed one is not in the right place. Dashed one is supposed to be going like... I could make this a lot better looking. Where'd my pencil's gone? And this one will go up here to that oxygen, which will meet that bond. There's an oxygen in the middle here. Look at this. Boom. Which will have it up there, which is the same as our product. Now these wedges are a little different here, those two, but the chirality should be still the same, I think. If it's wrong, then tell me, but these should be equal. So, I mean, that's all about what I have time for, all 22 minutes. Geez, this video has been taking long enough. But I need to figure out the acid catalyzation, breaking this bond, you know, and adding electrons, but we'll do that some other time. Anyway, yes.